If you ask a standard LLM, let's say unaugmented or non-agentic LLM, a simple question, can I recycle pizza boxes in Boise, Idaho? It draws on its parametric memory, which is essentially the statistical average of the entire internet. And since most cities in the world do reject greasy cardboards, it replies, no, food contamination makes them unrecyclable, throw them out, or compose them if you can. This is very convincing, but completely wrong in this particular case. It turns out Boise actually partnered with a specialized facility that explicitly accepts pizza boxes in their blue cards. Without RAG, the LLM relies on frozen training data or diluted details during pre-training or post-training steps. With RAG, it pulls the real, credible city documents and get it right. So with RAG, we have access to up-to-date, location-specific information to produce a far more accurate answer. However, you cannot manually paste a massive knowledge base into your prompt every time. There's going to be a context limit, there's going to be the cost factor. This is exactly where RAG automates. It dynamically fetches just the right amount of information that is most relevant to respond to the query of the user. Retrieval-Augmented Generation, or RAG, is the most essential architectural paradigm in LLM deployment. Let's see where RAG fits into our LLM engineering stack. When adapting LLMs to a specific task, we generally choose between in-context learning and parametric learning. In-context learning, like prompt engineering and RAG, allows us to feed external context directly to the model at runtime without changing its internal weights. No fine-tuning, no pre-training, no GPU required. They both operate strictly within the model's pre-existing parametric knowledge. This is the information that is baked into its weights during pre-training or fine-tuning. Now, if the model fundamentally lacks the facts or needs live data, we will hit the limits of prompt engineering. It doesn't matter how amazing you are with prompt engineering. This is exactly where you must move to RAG. RAG gives us the ultimate sweet spot here. High adaptability, zero weight, mutation risk, and extreme precision at a fraction of the cost. Another way to think about RAG and contrast it really with prompt engineering is that prompt engineering is static. RAG is dynamic. It's different for every query and with every context. So the next category is a parametric learning, which is out of the focus here. But these are techniques like fine-tuning and RLHF, DPO/BPO. They actually do update the internal weights. They change the mass and mechanics of the model. So at the query time, what does RAG actually do? Let's walk through a step-by-step, end-to-end workflow together. It starts way before anyone asks a question. That is where we prepare the knowledge base. We split our raw external documents into discrete chunks. We embed those chunks into high-dimensional vectors. Then we index them in a specialized vector database that is easy to search. When a user submits a query, retrieval kicks in. We convert the question into a vector using the exact same embedding model. Then we search the index and fetch the most semantically relevant chunks. Next is enrichment. We take those retrieved chunks, combine them with the user original query, and slot them into a structured template to build an enriched prompt, which is the question and all the context that LLM can rely on to answer the question. Finally, generation. We feed that enriched prompt to the LLM. Because the exact factual information are sitting right in front of it, the model doesn't have to guess or hallucinate. It just reasons over the provided context and produces a precise, grounded answer. So you probably have heard a lot of different intimidating names for variants of RAG: agentic RAG, corrective RAG, self-RAG, and there's so many other confusing names there. But don't get lost in the labels. Every one of them is just a different set of choices made at the same handful of steps that we're going to see here. If you understand these steps, the variance becomes very easy to reason about. At its core, every RAG system, whether it's a quick prototype or a full enterprise engine, comes down to three stages: ingestion, retrieval, and synthesis. Ingestion is all about building the knowledge base. This is offline. It happens before the user query comes in. This is where we prep the data. We load raw content from wherever it lives, chunk it into smaller coherent segments so retrieval stays precise, embed those chunks into vectors using a pre-trained embedding model, and then index and store them in a searchable vector database. Retrieval is all about finding the right context and data for LLM. When a query comes in, we embed it into the same vector space, then we can start searching for similar or relevant chunks. From there, we post-process, re-rank, filter duplicates, apply other techniques, post-process techniques, and format the best matches into a clean context for the model. Then we have synthesis, generating the answer. We construct a prompt that combines the retrieved context with user's query. You might be thinking why we need these steps. Well, we can feed the context in so many different ways to the model, right? We could feed the context to the model incrementally, giving it one chunk to draft the response and then other chunks one by one for the model to revise its answer. Or we could just feed everything to the model at once. One thing I want you to notice here is that ingestion happens offline, and the other two stages, retrieval and synthesis, happens live on every single click. But how do we evaluate a RAG system? Well, first, let's take a look at some common LLM evaluation metrics. So we have top 1, top 5 accuracy, perplexity that measures models' confidence or fluency, blue that checks exact n-gram overlap with reference text. But overlap is not accuracy. So all these measures fluency or surface level word matching. They do not measure whether the answer is actually supported by the retrieved document, which is the exact core question RAG needs answered. That brings us to a completely different framework for evaluation, and that is called RAG Triad, which breaks down an end-to-end evaluation into 3 distinct diagnostic relationships. The first one is context relevance. So this is the link between query and retrieve context. Did the retriever fetch the right context that actually contain the answer, or is useful to find the answer? If this is low, you don't need to touch your prompt, or we need to go back and fix our chunking strategy or embedding strategy. The next one is faithfulness. This is the link between retrieve context and response. This is our hallucination detector in a sense. Does every claim in the response come directly from the retrieved text? If this is low, tighten your system prompt or drop temperature to 0. And the last link is between response and query. Did the system actually, at the end of the day, answer what was asked? A response can be perfectly faithful, grounded to the context, but still fail to answer the actual question. Together, these pinpoint where the system broke, so you can exactly go there and fix it with the right strategy. So how do we run this evaluation now? These are just frameworks. There are different metrics you can measure, and there are different ways to measure those metrics. Well, we rely on 2 primary paradigms. We have reference-based evaluation, where you compare output against an expert gold standard answer. This is rigorous, but it's costly and slow. This is our preferred approach, but it's not always possible. For example, context relevance can be done in a ref-based approach, and that's what we're going to do. Well, you can just draw questions from a paragraph, and then in order to answer those questions, that paragraph is the right context. So we can create label data easily at a scale for context relevance, but for the other 2, it's going to be really difficult. So that's why we have another alternative paradigm, reference-free evaluation, or mostly this category is known by LLM as a judge, We use another LLM, usually should be a much more powerful LLM, preferably from a different family of models, to judge the answer provided by this model LLM. For example, if you're using Mistral 7B as your response generator, then you probably want to use a very powerful Claude or Qwen model as your judge.